Good morning. Today we are going to see the remaining questions of unit test 1, which are on unit number 2. So question number 3A and then question number 3B. So now we can have question 3A if we will see. So we have to go for torsion reinforcement. So discuss the torsion reinforcement. So we have to discuss torsion reinforcement. We have 3 marks. So this is given in Annex D, and you can see here D 1.8, D 1.9, and D 1.10. These are the 3 conditions. So now you have to draw the diagram and then explain the things accordingly. So now you can see torsion reinforcement shall be provided. Corner slab is simply supported on both edges. Meeting it shall consist of. Now see, torsion reinforcement shall be provided at any corner where the slab is simply supported on both edges. Meeting at that corner. It shall consist of top and bottom. Everything is given that you have to write. The area of reinforcement in each of these 4 shall be 3/4 of the area required for the maximum midspan moment in the slab. Then second, so when we do not have continuous edge, so here we have to provide 3/4 of ASTX at mid on this corner, that is in 4 layers. So you have to write there. Here you have to write corner A, then you write AST required equal to 3/4 of ASTX midspan. Provide 4 layers or 2 meshes at top and bottom with 2 layers in each mesh. With 2 layers in each mesh. So we have this is AST required. Then we have this is corner A. Then go for corner B. I will say this is continuous on this side and discontinuous on this. So I will write B, which is equal to 1/2 into AST for corner A. But you mention corner B, one edge continuous, another edge discontinuous. Corner A, both edges discontinuous. Corner C, you have to write both edges are continuous, and that is mentioned. Torsion reinforcement did not be provided at any corner contained by edges over both of which the slab is continuous. So corner C, no torsion reinforcement required, and for each one mark reinforcement is required. So you can write corner C first, you will get 1 marks, then write corner B 1 mark and 1 mark, that is for corner B. So likewise you will get 3 marks for each. Then we have designed a simply supported one-way slab 3.2 by 6.1. So it is given C, simply supported one-way slab. Now here you may confuse Ly by Lx less than 2. How one way? So if it is supported on longer edges only, supported on longer edges, then though Ly by Lx less than 2, it will be one-way slab. Then values, other values are given. So we will go now effective span little bit fast. Center to center, clear span. Now it is given passage. So we have to add width of support, which is given 230 means we have given a room and then we have to add supports in this. So we have this will be 230 supports on both sides. We require center to center distance. So we have to add BS by 2 from both sides. And then we will get it as BS. So 3.2 plus width of support by 2 on left and width of support by 2 on right. So these values half. So 3.43. Then trial depth we have L effective by D. Same. Assume modification factor 1.4. Calculate D. So we have that is L effective upon 20 into modification factor. Then we can have overall depth which is equal to 142.5 and we will get overall depth we will provide 150. So small d 130 millimeters. Then effective span we have clear span plus d. Clear span is given and d we have 0.13. So 3.33. Now minimum of 1 and 2 we have effective span and we have effective span 3.33 meters. So this is step 2. Then step 3 load calculations. Total load, dead load plus live load. Dead load we have self weight of slab plus floor finish. Floor finish that is given 1 kilonewton per meter square. If not given then we have to assume. If value is given we need not require to assume it. So floor finish is 1 kilonewton per meter square. Then total dead load we will get. So live load is given. Then we can find total load which is 8.25. So this load we can consider total load that is equal to W. So we have this will be W. Then we have total factorial load that is equal to WU and WU is 1.5 W. Then we have this value 12.38 kilonewton per meter square. Assume unit width. So it will be 12.38 kilonewton per meter. Then shear force and bending moment as simply supported. So WL by 2. WU we have calculated. This should not be W actually. This should be WU. And then we have value of V 20.61 kilonewton, bending moment WL effective square by 8, 17.16. Then check depth for bending moment consideration. Then we have design constant FCK and then we have Fy 500. So these two values are given. So always check this. This is most important. We have given 500, yes. And then we can have Ku max as 500.46, Ru max calculated 3.34. So D required we have 171.68, less than 130 mm. Therefore, okay. Then main reinforcement we can find. Substitute the values. Be careful. Fy is 500, FCK 25. And from this we will get AST required. So we have to check it with AST minimum, which is 0.12% of BD. And then we have this value 180 mm square, which is less than. So we have to provide AST required 319.28 mm square. Then find spacing. 8 mm square we have used. So overall depth of diameter, maximum diameter we should have 18. We will never go for this. Then find spacing. So we have 157. You can go for 10 mm also, no problem. And then we have this value that is 8 mm diameter bars at 150 mm center to center. Then we have AST provided. We have calculated which got as 335.1 mm square greater than 315, which is AST required. Then we have checked for shear. So maximum shear is at support. We are going to take 50% at top. So remaining steel is 50%. So steel available we have 159.64. And from this we have PT 0.13%. From table 19, as it is less than 0.15, so we have to take tau C equal to 0.28 Newton per mm square. Now see, in some books this is given K. Actually, we have to consider K. But if your value K that is greater than 1, if you will go to the page number 72, 40.2.1.1. Page 72, 40.2.1.1. And there they have mentioned this. K value 1.3, if we will not consider, it's okay, because that value again will be greater than VUC. Then check for deflection. So same way we have PT 0.26%. This is at mid span. Check for deflection we have at mid span. And then from this D required we have 122, we have provided 130 mm, therefore it's okay. Then distribution reinforcement we have to go for, and then we will get it as 270 mm center to center. And then you have to show it that it's simply supported. We are in this fashion. So I will just draw it. So likewise we have. So there, and then we have to show the reinforcement. So I will change the color just. So we have main reinforcement that is at bottom, and we got this value 8 mm tor at 150. So at support, we have reduced it 50%. So it is 8 mm tor at 300 mm center to center. Then we have bent up these bars at top from both sides. And we have this value, we have to find 15L, and then we have distribution steel. The distribution steel we have to show the dots because it is in this mesh. And we have calculated this value 8 mm, that is at, so we have 8 mm tor at 270 mm center to center. So you have to draw this diagram actually. Then we have question number 4A, where we have to explain conditions to use one-way slab coefficients given in IS code. And now you can see you have to go for three criteria in this. So first criteria we have more exact analysis is not required. Exact analysis is not required. This is our first condition. Second, they have given a here you can see redistribution is not allowed. So second condition, a redistribution is not allowed. Redistribution is not allowed. And third condition that is given, so it is mentioned, you can see over here, that is 15% of the longest. Minimum 3 spans required. Minimum 3 spans are required. And then we have fourth condition. So they have given here, you can see, no, sorry, we have three conditions only. Yes. So we have these three conditions, that is to use one-way slab. And we have to keep in mind for each we have 1 marks. So then we have question number 4B, which is for continuous slab. So I will, you know now, L effective. Now keep in mind, effective size is given. So we need not require to go for center to center and L clear span plus D. Directly L effective is given. Then we have trial depth. Now as it is continuous, we have to take value that is equal to 26. Then go for assume modification factor 1.4. So now actually effective span mark distribution, that was not I also mentioned in last. So we have 1 mark for this. And then we have trial depth. We have for trial depth. So provided, and for this we are going to get 2 marks. sorry, we have 3 marks, finalize. So we have this as 4 marks. Total we have question that is given for 12 marks. Then we have load calculations. So same, I will not just repeat it. So we have these values, and then we are going to be for final, that is 10.95. So already we have 5 marks. Then we are going to get 2 marks over here. So we have 7 marks over here. Then we have assume unit weight, then shear force and bending moments. So as beam is continuous, so it is actually not simply supported. We have beam is simply supported, not beam is continuous. Beam is continuous. Therefore, we have to use that is annex D, and by using this, we have to find value of WU Lx square WU, and from this we have to find value of moments, and then we have these moments. So now we are already 7 marks. So here we will get it as 2 marks again. So here some may change this distribution, but generally we are in this fashion. 2 marks here. So we have 3 to 5 to 7 to 9. Then we are going to be with design constant D, and then we are going to be 1 mark over here. Then we can have reinforcement. So we have calculated now reinforcement, that is for both. And then we have actually 1 mark over here. And then we have to show the diagram. And for showing the diagram, we have 2 marks. 2 marks for diagram. So we have 2 plus 1, 3. Then we have 1 mark, 4. Then we have 2, 7, 2, 9. Sorry, here we have 2 marks only, 9. Then 2, 11. And then we have 1, that is 12 marks. So similarly, if we will go in one-way slab, then in one-way slab actually, we have less step compared with that one, more step. So this is 1 mark. Then here you will get 1 mark only for trial depth. So 2 marks. Then we have load calculations. Then we have again 1 mark for this. Sorry, 2 marks, 2 to 4. Then we have bending moment and shear force. So we have bending moment and shear force. We will get again 2 marks. So it goes 6. 1 mark for this. So we have 7. Then reinforcement, we have both distribution, 1 mark. So here we have 1 mark, that is 8. Then shear check, we have 1 mark, 9. Then check for shear, 1 mark. One mark. Then check for deflection, we have 1 mark. And may we have change, and this diagram we have 2 marks. So some here and there we have. So likewise we have, that is distribution. Someone may give 1 mark for the diagram. Someone may consider 2 marks for the diagram. So likewise we have, that is distribution of the marks for the problems. So now we will stop here only. The remaining part we will see in the next lecture.